Let's go ahead and take the schematics we just created and wire up a PCB board. So first, let's go to our sensor breakout.pcb doc, and with every new project, we need to set up these layers again. So this is something that we did before when creating a footprint for the sensor, and we're going to do it for the PCB project. So I'm going to turn on top layer, bottom layer, overlay, solder, board outline, 3D bodies, top assembly, and bottom assembly. And I will also, in view options, turn on transparency. It'll just make seeing all of the components layered on top of each other a little bit easier. So each fabrication company has different rules for how far certain parts can be separated, how big vias can be, how thick wires can be. And we are going to go ahead and import rules that have already been made based on the fabrication company that this board is going to be created by. Go ahead and Control A, so you select everything. And navigate to wherever your senior design.rul is. Go ahead and clear the existing rules. That's all changed, so apply and OK. Now our setup is pretty much done. Let's import that schematic. So import changes from schematic. Execute changes. No errors came up, good. I'm going to make a little bit more space here by closing this down. Now you'll see that we have our parts here. I'm going to delete this red box. It's just there as a temporary thing. Now I feel like in order to make these header pins separated the right amount, let's go ahead and create a grid size of 2.54 millimeters so that as we place these down on our PCB, it'll be easy to plug into a breadboard. So I'm going to change from mils to millimeters, so tap Q. So you should be in millimeters, grid, set grid properties. Let's turn on lines, and let's make this 2.54 millimeters. Now you'll notice these green X's here. So if I hover over it, you'll see on the top left it says constraint, yada yada, between this and this. So that's because there's a collision, and Altium will automatically detect if something is wrong. And it's your job to correct whatever it is. Now the first thing I'm going to do is I'm going to remove these silk descriptors because as you'll see, it's redundant. We have C1 as part of our top assembly here, as well as on the silk. Now we aren't going to use the silk version because as we're compacting this design together, there's not going to be space for it. So I'm going to go ahead, do find similar objects, and I'll just select everything that's a silk label and get rid of it. Perfect. Now, right now, this PCB is pretty big. It's a lot bigger than we need. So this is where we're going to use the board outline layer. And I will draw a line surrounding the area that I'd want this PCB board to be. Escape, escape. I'll go ahead and select our box. In design, board shape, define from selected objects, and you'll notice that our board became a lot smaller. The second thing I'll do for that is reposition our origin at the center of the board so that our dx, dy, and our x and y are relative to that center point. Now at this point, we are going to start routing. And so a grid of mills is easier for routing. So I'm going to tap Q. So this is mills. Let's change our grid properties. The fab we're using is going to work in granularities of 6 mil. So I usually like to add 6 mil as a grid size. All right, so let's do a little bit of planning here. So we'll see that we have int, SCL, SDA. Seems like int is down here, SDA, SCL are up here. So it might be a smart idea to rotate this. We have NCS is up here. This guy is down here. So I think this is a good idea to rotate him as well. And that looks pretty good. Just going to organize these capacitors. So he is connected to reg out. I'm going to add him here. This one is connected to VDD, so I might add him here. And this other one was connected to VDDIO, so I'll add that here. I'm going to try to get things to line up nicely, just for clarity. So I think that's about right. Great. I'd say as an overall placement, this looks good. I'm going to use this interactive routing connector. And let's start with VDD. Now SDA is being blocked right now by this wire that we routed for VDD. So I'm going to go ahead and create a via. So I'll go to the bottom layer. It will automatically create a via. We can move over here, come back to the top, and continue routing. All right, so we've connected most of the signals. Right now we don't have VDD connected all the way, ground as well. What we are going to do instead is add a polygon pour. I'm going to change my grid to something a bit more coarse. And we're going to make this polygon pour VDD. And hopefully that will help connect some of our VDD signals. Tools, polygon pour, and repour all. And you will see that our VDD is now connected on both sides, including connected to this. Now for ground, we will create another polygon pour, but we will create it on the back end. So I'll go to bottom layer. Let's create another pour. And we will make this one ground. Now we have to repour after each time we create one. Otherwise there's going to be collisions because it hasn't updated based on the wires that exist already. Now right now our grounds are still not connected because we need to actually create vias to go to the ground layer. So ground, let's go to our bottom layer. Let's just test this. So if we do tools, polygon pour, repour all. Okay, so our ground is now connected by going to the bottom pour. Okay, that looks good. So I don't see any more unconnected wires. We're going to go ahead and do a design rule check just to make sure that we haven't forgotten anything. So it looks like there are no errors, which is good. Now let's take a look at the board. So I'm going to tap 3, so we go into 3D mode. And this all looks good. The only issue is there's no way of knowing what pins connect to what. So we are going to go ahead and add some Silkscreen on the back to signify what each of these pins are. So I'm going to go to our top overlay. And I'd actually like to turn on the bottom component of it because we're going to go on the other side of the board. So the bottom overlay, and I'm going to put a text string. Let me change my grid to millimeters. Put one right there, one right here. Now I believe these may have to be mirrored. Let's take a look in 3D mode and see. So I'm holding down Shift and I'm just dragging with my mouse. We can also go on View, 0 rotation. Yeah, so we need to mirror these. And let's change our text height to something a bit smaller, maybe like 40. Let's take my grid down. And that's about right. And I'm going to go ahead and copy and paste it so we have on the side as well. And let's just go ahead and give these guys names. All right, let's take a look one more time. And that doesn't look too bad. So these are the labels in Silk that will correspond to the pins on the other side. Just makes it a lot easier for when you plug it into your breadboard. The last thing I'm going to do is just a minor cleanup. All of my vias, I'm going to make tented vias. And so instead of having a hole there, the hole will be covered up. And that will just make reading these a little bit easier. All right, that should be it. So we have just created a footprint for the sensor part. We created the footprint for the header and the capacitor, made the schematic symbol for it, created a schematic project design, and then imported that schematic design into our PCB, created a nice little board, and we can double check everything using 3D mode.